Alright, so hello everyone. In this video we'll be looking at the third exercise of session 1. So I'll remind you what the statement was. It asked us to consider the following equation, which is that the time derivative of a certain function u is equal to a function of the same function. And we also consider the general implicit time integration scheme, which is given by the equation here, and that is parameterized using a parameter theta, which takes its values between 0 and 1. And the question is to determine the order of precision of this time integration and to determine for what values of theta is the order maximal. So to solve the problem, we start from information we got from the statement, which is that the time derivative of u is equal to a certain function of u. So we had the idea of performing the Taylor series of f of u using the stencil that we have drawn here. So there is a time increment delta t between two successive solutions at step n and at step n plus 1. And so the Taylor series that we have performed here is fairly standard. I don't think there's much to say about it. And then we can, let's say, expand upon this series by replacing all the time derivatives of the function f with time derivatives of the function u by using this information here. And so we would get that the time derivative of f is equal to the second time derivative of u, and that likewise the second time derivative of f is equal to the third time derivative of u. And so we can plug this into the Taylor series to get the equation number 1 here. Okay, so and on the other hand, we can also use the implicit time integration that is given in the statement, which we have rewritten here, and manipulate it so that we have a form that is similar to what we have seen in the course for finite difference. And if we plug equation 1 into the equation we have just written here, we get equation number 2. So it's just mathematical manipulation. And finally, we also look at the Taylor series of the function u, and the Taylor series is done again in a very similar way as to what we have done for f. And again, we can write it in terms of a finite difference to get an equation labeled here 3. And if we combine equation 2 and 3, so if we compare them, we get that we can write the time derivative of u at a certain step n as a function of mu n, of theta, of delta, of the time increment, and of the other order of time derivatives of the function u. And we can draw some conclusions from that last equation. And these conclusions are that if we replace here in the equation theta precisely but by 1/2, we see that this second term here, which is multiplied by a delta t, vanishes. So we would only be left, as we have written here, with terms multiplied by delta t squared. So we would have a second order precision in that case. And in the other cases where we would take any value of theta that is different from 1/2, then we would have a first order precision, because we would have still the terms depending on delta t. And thus we get a maximum precision for theta is equal to 1/2. And so that solves the question. Thank you very much.